All right, physics class, let's look at the second part of our notes here. And if you would, in your notes, turn to this problem. I'm going to walk you through this, and actually what I'd like you to do maybe is just pause this video and try to solve this on your own. You'll notice that they give you some knowns and some unknowns, and then choose the correct formula and see if you can solve it. And then come back and see if you can get what I get. In this problem, it's talking about a ball's motion, and it is being rolled up a slanted driveway. The initial velocity is 1.25 meters per second. Let's write that down, 1.25 meters per second. Okay, and it travels upwards while slowing down. It's going to slow down, and it's slowing down for 4.22 seconds when it stops. So that means the final velocity is 0. They're not going to state that explicitly. You're going to have to figure that out as it comes to a stop. And that happens 4.22 seconds later, after it starts rolling up the hill. We are asked to find the acceleration. So A is what we're trying to find out. I look at my variables, my knowns and my unknowns, and I figure out I need an equation that has acceleration, final velocity, and initial velocity in it, and time. Well, that is, actually the definition for acceleration is the change in velocity, final minus initial, divided by the time. So I just have to plug in those values. My final velocity is 0, initial is 1.25, divided by the time of 4.22. You're going to take out your calculator and find out what that value is. You can finish that up. I'll point out that this should be a negative number. Why? Because it's slowing down. It's going up a ramp. It's going up a ramp, and it's slowing down until it comes to a stop up here, and that's the movement that we're interested in. If it's slowing down, it means the acceleration is going to be negative. This acceleration, when you get the answer, has to be expressed in meters per second squared. Meters per second. Okay? So as mentioned, the definition for acceleration is the change in the velocity over the change in time. And that's what was given to us. Units have to be for acceleration in meters per second squared. And yes, it makes sense. Okay. There are 3 ways that an object can accelerate. Basically, it can increase acceleration, it can decrease its acceleration or decrease its speed or velocity. It also can change directions, and we didn't talk about that too much, but if it's changing directions, it is technically accelerating, like going around a curve, okay? So it can speed up, it can slow down, or it can change its directions, and that is also a type of acceleration. Let's look at number 12 here. Read this carefully. Again, you might want to pause the video, see if you can do it on your own, and then come back and work with me, and we'll check. This says 2 joggers run at a constant velocity. They're both running at the same speed, and they're going in the same direction. They're both going east, so they have the same velocity. Notice that they're starting at different positions. Their positions are at time 0. So it says, what would the differences in the position time graphs look like for their motion? Well, if I did position time graphs, the blue runner is starting back behind the origin, if this is like the starting line there, or a reference point. He's starting down here at negative 15, okay? This is position and time. The orange guy is starting beyond the starting line. So he's starting up here at positive 15. Okay, still position and time graph. The difference is where they're starting. So again, the orange runner is starting beyond the starting line, the origin there. The blue runner is starting behind it, so we have to put them at negative. They're both running at the same velocity, which means once they take off, they are going to have a line here that is describing their velocity, which is the change in distance over change in time, and they're going to be, those two lines are going to be at the same slope because they're running the same velocity. Okay, the only difference between these two runners is where they're starting. The blue runner and the yellow runner, the blue will never, this guy will never catch the orange runner because they're running at the same speed. He's behind him, he's 30 meters behind him, and he'll stay 30 meters behind him. Okay? So that would answer question A. If we're looking at velocity time, well, velocity time doesn't care about position. It's just looking at their velocity. The velocity time graphs would be exactly the same. You would have the velocity and the time for the blue runner. He's running at 7.5 meters per second. So at 7.5, you would have a line going horizontal. His velocity never changes. From time 0 until he stops, his velocity is the same. And it would be exactly the same for the orange runner, exactly, because his velocity is also 7.5. So we would have a horizontal line at 7.5. This is velocity versus time. His velocity doesn't change. It's not that he stopped, but the velocity is constant, okay? That is also shown over here. When you look at a distance time graph, this right here is showing you, since this is a line, that this is a constant velocity. It's a constant change in its position over time. And remember, you could find that actual slope, we're given to it, it's 7.5, but you could find it by doing rise over run, change in the position over the change in time. And you could find that slope, and it should be equal to 7.5. Okay, let's come down here. This one is showing, asking us to sketch a velocity time graph for a car that goes east at 25 meters per second for 100 seconds. And then it's going to go west at 25 meters per second for 100 seconds. Okay? So direction matters here. Again, if you want to pause the video right here and try to graph this on your own and then come back. Okay? But notice that they give us the velocity that he's starting at, and he's going east, which means if we want to say east, like up here, if we want to say east is positive, this is the positive direction here, positive going that way, negative going that way. So he's going east, which is positive, so I'll put a little positive here in front of the 25. This is positive. This one is going west, so that's going to be a negative. So he's starting out at 25. Meters per second. That's his velocity. This is velocity and time. And so in this case, he's going to go 25 for 100 seconds. So let's just say that's 100 seconds right there. Okay? Then somehow he's able to instantaneously turn around and change his velocity, and now he's going the other direction because it says he's going west. Well, that means we're going to be way down here. Negative 25. Now, this is unrealistic. Obviously, you can't just stop, turn around, and go the other direction instantaneously, but in our simple problems, that's what's happening. And now he's going to go negative 25. Okay, this is velocity and time. Because this line keeps going this way doesn't mean he's going in a positive direction. It means that he's continuing to move, but he's moving at a negative velocity. So he's actually moving west. When he's moving east here, he's moving west here. Because this is negative east, he's moving in a positive velocity. Okay? Okay, let's try to answer this one. Again, if you want to stop it and come back, that'd be great. We're not going to do part B of this, don't worry about that. But let's look at part A. It says find the average velocity. Average velocity is the change in the displacement over the change in time. What's his total displacement? Not total distance, total displacement. So in this case, what happens is the canoe goes upstream at 2 meters per second for 4 seconds. So let me draw a diagram, it's helpful. It goes upstream, and if he goes 2 meters every second, and he does that for 4 seconds, 2 times 4 is 8. He has gone 8 meters upstream. Okay, I got that because it was just the 2 times the 4. That's velocity times time. Okay, velocity times time gives you distance. Then he turns around and he's coming back. Well, how far does he come back? It says he goes downstream faster at 4 meters per second for 4 seconds. Well, 4 times 4, that is 16. He comes back 16 meters. How did I get that 16? 4 times the 4 from here. Again, it's just velocity times time. So he started here. Let's say that's 0. He ends up here. I don't care that he went upstream and then came back down. I'm just interested in his starting position. We'll call that xi. And his ending position. We'll call that xf. That change is what gives me my velocity over the change in time. So I want xf, if you want to call that, is he's at -8. He went up 8, came back 16. He's at -8 now. He's below where he started. So -8 minus 0, 0 is where he started, over the time, well, 4 seconds and another 4 seconds, 8 seconds. And so I take my -8 divided by 8. That's a -1 meter per second. He's going downstream, okay? Downstream at an average velocity of 1 meter per second downstream. That's why it's negative. Okay? Okay. I'm going to skip ahead a little bit here. And let's go to some other problems where we are using our kinematic equations. Okay? This one is saying that the velocity time graph shows the motion of a car traveling at a constant velocity. There's a constant velocity, and we want to find out how far has it gone in 10 seconds, how far has it gone in 20 seconds. So just write down what I'm given. I am given the velocity, and I'm given a time. We'll just do one of the times at a time. So I'm given velocity and time, and I want to find what? I want to find x, the displacement. We'll do the first one, and then we'll do the second one. Well, if I have velocity, time, and distance or displacement, that is this equation. Velocity equals change in displacement, or the distance, over the change in time. We've been kind of writing it just as distance over time. And if you want to find distance, then you're going to solve for distance. Distance is equal to velocity times time. So all I'm going to do here is for each of these times, I'm going to take the velocity times the time to find the distance. Distance is equal to velocity times time. So for the first one, you can use d or x. Okay, it doesn't matter. I put x originally. I'll keep doing x then. So x here, the x1, the distance that he travels initially after 10 seconds is 37.6 meters per second times 10. So he goes 376 meters. If he goes 20 seconds at the same rate, well, do the same thing, just multiply by 20 instead of 10. Okay? All right, there we go. All right, another one. It says use the relationship among, oops, sorry. No, let's move on. We already did that. We just did those problems. Here, let's do another one with our equations. Read it carefully. As you're reading, start to write down your knowns and your unknowns. Starts at rest. Be careful. That right there, even though they're not giving you a number, starts at rest. That means the initial velocity is 0. And it accelerates at, they're giving you an acceleration right there. 5.7 meters per second squared. How far will it go when it is traveling 15 meters per second? In other words, it's going to go from 0 up to 15 meters per second. Once it's reached that 15 meters per second velocity, how far has it gone? The xi here, I mean, you can call it 0. You really don't need it. It just says that it's starting at 0. Let's say that xi is 0. We want to find how far it's gone. I look for an equation that has these variables. I'm looking for an equation that has distance in it, initial velocity, final velocity, and acceleration. There's my x or my d, my distance. There's acceleration. There's my initial velocity. There's my final velocity. That's the equation I want. I'll make sure that you have it on the test. You just have to know which one to choose. So I'm going to plug these numbers. I plug the given values into my equation. Oops. Final velocity is 15. Don't forget to square it. The initial velocity is 0, so that's just going to be gone. Plus 2 times a, 2 times a times the d. Oops, I back up here. I know the a. Sorry about that. 2 times the a, which is 5.7, times the d, which I do not know. So I'm going to have 2 times 5.7. 15 squared is 225 equals, and 2 times 5.7 is going to be 11.4, and then you divide by 11.4. You can do that on your calculator, and when you do, you will have the distance equals whatever that number is, and distance is going to be in meters, because they gave us the velocity in meters per second and acceleration in meters per second squared. Okay, you can do that. Don't forget the units. Okay. So again, if you are given the initial and final velocities and acceleration, what would you do to find the distance? Again, you look for these 4 variables, and the formula that has those 4 variables is what you would choose, and we just did that. We used the final velocity, we used the initial velocity, and we used the acceleration and the distance. Okay, so let the variables lead you to the correct formula. Okay? Let's look at number 34 together. We are going to be finding acceleration, looks like. Okay. A woman's driving west along a straight road. Speed is 23. Okay. You are given the initial velocity. Sees a deer on the road ahead. She applies the brakes. Going to be slowing down when she is 210 meters from the deer. If the deer does not move and the car stops right before it hits the deer, what is the acceleration? She stops, which means the final velocity is 0. During that stopping process, she travels 210 meters. That's your distance. And you want to find the acceleration. These are the same 4 variables. Okay, just this time we're solving for acceleration instead of distance. So to do this, you're going to find your formula and just write it up here. I have a little space. Okay, same formula. I am given in this problem the initial velocity, the final velocity, and the distance. The initial velocity is 23. Don't forget to square it. The acceleration I do not know, and the distance is 210. The final velocity in this case is 0. Okay? So you're going to take 23 squared This is all being multiplied together. 2 times a times 210. I don't know what a is yet, but I can take the 2 times the 210. Now I need to get this a all by itself. So I want to subtract 529 from both sides. And then divide by 420. Okay? That's going to give me my a value. Negative 592, sorry. Oh, sorry, it's 529. Sorry, I keep writing. I wrote that incorrectly there, sorry. 29 there, sorry. 29, 529 divided by 420. Whatever that number is, that's your answer, and the units are meters per second squared. Okay? Okay. Number 35. Airplane starts from rest right away. They're giving you initial velocity is 0. Accelerates east at a constant 3 meters per second squared. They're giving you the acceleration. For 30 seconds, they're giving you time. Okay? It wants to know how far did the plane go before it took off. So that means I want to find, for this one, I want to find D. So I need an equation that has VI, acceleration, time, and I want to find distance. I need these 4 variables in my equation. And when you look at the different options, there's one that says this: distance equals 1/2 AT squared plus VIT. This has the 4 variables that you're looking for. Let these 4 variables point you to that correct equation. And now I just plug them in. This is 0. 0 times 30 is 0. So I need 1/2 times 3 times 30 squared. So 30 squared is going to be 900. Half of that is 450 times 3 is going to be 1350, I think, if I did that correctly. Let me just double check. You can do that on your calculator as well. Okay, you found the distance. How fast was the airplane going just before it took off? Well, now I want to find not distance. This was part one. I found distance. Now I want to find the final velocity. Okay, now I found distance, so I could find an equation that has distance in it if I want to, but I definitely need an equation now that has the final velocity in it. Okay, final velocity, I now have distance. I could maybe find one that has time in it too, but I have acceleration and initial velocity. Those four variables are this equation. Okay, this time I'm solving for the final velocity. Plug in what I know. The initial velocity is 0, so anything squared, 0 squared is still 0, plus 2 times a, which is 3, times the distance, which I just found up here from the previous part. So I'm going to take my 2 times 3 times 3, 1350. And that's going to give me the square of VF. So I think I get 8100. Don't forget now, this is VF squared, so I have to take the square root of both sides. So that means the final velocity is the square root of 8100, which is going to be 90. 90 meters per second. Okay? So try number 36. Inline skater accelerates. They're giving you the acceleration. Oh, actually, they're just giving you, they're saying it accelerates from 0 to 5 meters per second in 4.5 seconds. Okay? And then continues at that constant speed for another 4.5 seconds. So this might be a good place where you draw a diagram. So the skater is going to go for an initial 4.5 seconds. Here he's going 0, and here he's going 5 meters per second. And that happens 4.5 seconds. Then he's going to go another 4.5 seconds at whatever velocity this is. At that point right there, whatever the velocity is at that point, he's going to continue, and he's going to continue for another 4.5 seconds. Okay, so we're going to kind of break this into two parts because I need this velocity. I need the velocity that he is traveling at after the initial 4.5 seconds. Okay? Oh, actually, it's right here. I'm sorry. It's right there. The 5 meters per second is that velocity. Okay? So we need to find, we're trying to find distance. So I want to find the distance here in this part, and then I want to find the distance in that part. It's two parts, distance 1 and distance 2, and we're going to add them together. Okay? So I can find the distance here. I'm looking for a formula that has distance, which is what I want to find, and I'm given the initial velocity, is 0. I'm given the final velocity is 5. And I'm given time, which is 4.5. Okay? So basically, I know that velocity, average velocity, is the change in the distance over the change in time. Okay? So right there, I'm going to spill into this problem here. I know that the velocity here, the average velocity, is the change in distance over the change in time. Okay? I also could find the acceleration here. I'm just going to check something. Let's find the acceleration. The acceleration is the change in velocity. It's going from 0 to 5. So 5 minus 0 over the time of 4.5. This right here would give me my acceleration. Okay, it might be easier to do it this way. We'll see. 5 minus 0 divided by 4.5. Okay? So he's accelerating at 1.1 meters per second. Squared. If you have acceleration, now you could use that here maybe to find the distance traveled during this first part. Okay? If you know the acceleration, getting kind of messy here, sorry. If you know the acceleration and then you know the time, the initial velocity and the final velocity, we could find that distance. Yep. So we could right here, ladies and gentlemen, use the same formula. So the final velocity is 5 squared. The initial velocity is 0, so we don't have to worry about it. And 2AD, we just found the acceleration. So 2 times 1.1 times the distance, which is what we want to find. So for this one, you're going to take the 5 squared, which is 25, and divide by the 2 times 1.1, which is 2.2. Okay? That's going to give you 11.36, 11.4, we'll say. Okay? So 11.4 is your distance. That's meters. So we want 11.4. That's for the first part right there. The second part's easy because we know he's traveling at 5 meters per second and he's doing that for 4.5 seconds. So we're just going to take distance equals velocity times time. 5 is the velocity times 4.5. Okay, 4 times 5 is 20. Half of 5 is 2.5, so 22.5. You're going to add these two together. This is the total distance. 11.4 and 22.5 gives you the total distance. I'll let you do that. Okay. All right. Let's go on to a few more here. I'm just trying to give you as much as you possibly can have in order to get ready for this test and walk you through a few of these problems here. Let's see here. All right, 37. We're doing the same thing every single time, ladies and gentlemen. All right, all I'm doing is writing down what's given. Plane travels a distance. Distance equals 5 times 10 to the second meters. That's just 500, okay? while being accelerated uniformly from rest at a rate of this. So they said rest, which means the initial velocity is 0, and the acceleration, they're giving it to me, 5 meters per second squared. Okay? What is the final velocity? I want to find final velocity. I need an equation that has final velocity, acceleration, distance, and initial velocity. And it's that one we've used before. The final velocity is what we're trying to find. The initial velocity was given to us at 0, so that term is gone. And then 2 times A is 5. Distance is 500. Evaluate that and take the square root, because it's v squared, so I have to take the square root to get v sub f. Okay, 1,000, 5,000, and then you're going to take the square root of that to get your answer, and that would be in meters per second. Okay? An airplane accelerated uniformly from rest at a rate of 5 meters per second, so they're giving you the acceleration, meters per second squared. South of 14 seconds, what is the final velocity to attain? Okay, it's the same type of problem, but we're going to use a different equation. This time they're giving us time. We are told that it started from rest. And we want to find the final. You have to search for a formula that has those 4 variables in it. And when you do, you will find this one. So the final velocity is equal to the initial velocity, which is 0, plus the acceleration times the time. Acceleration is 5, time is 14. You multiply those together, and you'll have your final velocity in meters per second. Same exact steps. Find what is known and unknown. Let that point you to the formula. Plug in your values. Evaluate. Make sure you got the correct units. Does it make sense? Okay? Okay, I am going to stop right there, and we'll pick this up next class as we look at free fall, which is basically just still one dimension. It's just looking at motion. We've been looking a lot at horizontal motion, but free fall is just the same thing. It's just, you just turn it 90 degrees. Okay, you're going to have an acceleration. Acceleration when something is falling is 9.8 meters per second squared. So we're going to be looking at that and see how that applies. All right? All right, let me know if you got questions.